If the water velocity is in the bigger pipe is 3.05 meter per second and the pressure is 414 kilopascal, and find the pressure at point B. The frictional loss between point A and B is 7.62 meter. Okay, first jot down all the information from this question. Bigger pipe, it is point A. So PA is equal to 414 kPa, and the velocity in point A is equal to 3.05 per second. And then the frictional loss is also known as HL. HL between point A and B is equal to 7.62 meter. And then write the Bernoulli equation. PA equal to lambda over lambda 2A dg b dash 1 is equal to db by 2b to b z. B L. Then cut down all the unused unused formula. So there's no pump here, potong pump, no turbine, and ZB is equal to 0, potong ZB. Okay, then we need to find velocity in point B. To find velocity in point B, we use the continuity equation equal to AB over BD. The meter in point A is 0.1 meter, the meter in point B is 0.05 meter. Use this information to find the area. VB, VA, equal to 0.5. Kira semua ni. VB is equal to 12.22 second. After you get VB, just put in all the number in the equation, all the information in the equation. VA is equal to 414. Since we use water, the lambda is equal to 9.81. 3.05 to 9.81. ZA is equal to 4 meter. Question is asked to find PB. So velocity in point B is equal to 12.22, and the HL is equal to 7.62. Calculate all the information given. calculate this side equal to 5 8 minus, and the information from this side pindah ke sebelah, so ditolak. 23 is equal to VB over 2 and 1. Calculate semua, so the answer is equal to PB equal to 357.57 kPa. Okay, for this question, the pressure gauge read 140 kilopascal. If the head loss along the nozzle is 2 meter, find the volume flow rate and the water flow. Okay, first we need to find 2 points in this diagram. We choose on the open surface of water surface is point A, and at the nozzle is point B. And then jot down all the information given. Pressure gauge read 104. This is pressure for point A. Since point A is in a closed space, so they have a pressure of 140 kilopascal. Then the head loss along the nozzle is 2 meter, so HL is equal to 2 meter. Question asks us to find the volume flow rate of the water. And then write down the Bernoulli equation. PA is equal to lambda plus B2A 2G B HL, and then cut down all the useful information, all the unused information. ZB is equal to 0, so it is the lowest elevation. There is no pump here, cut down pump. No turbine, cut turbine. And then pressure at point B, since it is on the open surface, not in a closed space, so the pressure is equal to 0. And then at point A, it is on a water surface, open surface, so the velocity is equal to 0. Key in all the information given. 140. The lambda is equal to 9.81 because we use water as a liquid here. Plus that A is equal to 2.4 meter. Is equal to VB plus HL is equal to 2 meter. Calculate all the information given. So HL tekan di sebelah ditolak 0.67 minus 2 19.62. Calculate semua ni is equal to VB 1.7. Okay. After After we get VB, then we can find the volume flow rate of the water. So volume flow rate is equal to AV. In this question we use VB. The area of VB is over 4 time VB. VB is equal to 16.97. Calculate all the information given. So volume flow rate is equal to 0.00033 meter cube per second. Question: if the water is flowing at 0.006 meter cube per second and the frictional loss along the flow is not negligible, find the HL. So the question asks us to find the head loss. First, write down all the information given from the question. Since the water is flowing at 0.006 meter cube per second, this is our flow rate, volume flow rate of the water. And then find 2 points in the diagram. I will choose point B here, point A here. See, this point, because it is easy for us to find the pressure between point A and point B. And then write down the Bernoulli equation. VA and ZA and cut down all the unused information. Since we don't have pump and turbine, we need to cut them down. And A is at the lowest elevation. We need to cut ZA down. And that's it. After that, we need to find the lambda for this SG. 13.6 and 6 times by 9.81 is equal to 133.6. For that, since we have the volume flow rate, we can find the velocity for point A. So V equal to A of VA. So VA is equal to 0.06 over the area. Diameter is 5 cm, so we need to convert it to meter. So it is equal to 0.5 meter over 4. And we get 3.06 meter per second. After we get VA, we can find the velocity for point B. VA is equal to AB VB. We're going to verify. So we calculate all this. So we get VP is equal to 0.765 meter per second. Then we have the velocity for point A and point B. And then we get two more information. We get to find two more information, that is the pressure between point A and point B. To find the pressure between point A and point B, we use the manometer equation since manometer is given here. So PA plus P water 1, since it is going down, it's a plus, and minus P, I put this as a mercury because the lambda is equal to the mercury, minus P water 2 is equal to PB. PA minus PB is equal to PSB plus P water 2 minus P water 1. 2.416 0.25 plus 9.81 1.1 minus 9.81 0.25. After we calculate all this, we get 55.03 kilopascal. So we have the information for pressure difference between point A and point B, and then we can find the head loss for this question. We write down the Bernoulli equation again. PA to PB, so PA minus PB, so PB mesti pindah sini, and VB pindah sebelah juga. So the equation will be PA minus PB over lambda plus VTA minus VB equal to 2B, and then ZB is equal to 1.2, pindah sebelah ditolak, equal to 1.2 equal to HL. With all the information given, 55.03 is equal to, since in the big pipe we use water, so the lambda is equal to 9.81 plus the velocity at point A and point B over 2 minus 1.2 meter. So HL is equal to 4.85 meter.